WLAN network plan and the typical case. Objective: describe WLAN typical application, WLAN design process, understand WLAN design method, WLAN typical application. So this is an example of the application, including the campus, public area, exhibition center, office building, hotel, industrial park, residential, and pedestrian. So all those locations also require the WLAN to perform the wireless coverage. So of course, different application, the requirement for the AP and the configuration might be different. So here giving some example, the scenario and the characteristic. For the scenario campus, there's high user density, a large number of concurrent users, high bus traffic, and high network quality demand. Okay, so this is happening to the campus. Campus basically have a lot of the user, and you would like to have the high network quality. Scenario meeting room, exhibition center, same, also have high user density, large number of the concurrent user. So basically from here, the meeting room and the exhibition center similar to the campus. The only difference here is when in the scenario exhibition center, they might have the wide and open area. To the hotel, they have a low user density and few concurrent user. So basically one hotel can be very big, and a lot of the guests will going to stay in the hotel, but doesn't mean it's everyone will going to connect to the Wi-Fi, because people will going to stay in the hotel. They actually is only at the night time. Okay, so that's why they put low user density and a few concurrent user. Low continuous traffic. They are not going to stay at the hotel for very long, because early morning until evening time, maybe they have some work or they go outside. So only evening time they return back to the hotel. So there's a very low continuous traffic. Wide coverage area and the signal blocked by the wall. Then the next one is the entertainment place. Low user density, low continuous traffic, small coverage area, and open area. At the entertainment place, basically less people will going to connect to the wireless. Okay, even yes, they just connected, but they less access to the browsing the web. Okay, because this is the entertainment place. Who going to go to the area there and just take out the phone or take out the laptop and browse the internet? Or maybe yes, they just doing some survey. That's all. Okay, it's only for the very low continuous traffic. Transportation hub. So they only have a temporary tour, but they require a very wide coverage area, open area, and no network quality demand. There's no importance on the quality, because all the guests staying in the transportation hub is just for temporary. And the last one is the office. High user density, continuous traffic, and the network quality demand. In the office area, yes, you need to make sure the traffic quality. They have many employees staying in the office, and the traffic is always continuous. For the device type, indoor sector AP. The feature for this is high bandwidth and simple deployment. Suitable for the scenario, it requires a high user density, the large number of a concurrent user, such as the multimedia classroom, meeting room, and the exhibition center. Indoor distributed AP, single space, flexible antenna system, large indoor coverage area, and low cost. Instead, I'm going to deploy so many AP in the scenario like hotel. Basically, a hotel in one floor might have many rooms. Impossible you're going to deploy so many AP in the same flow, then you'll be overutilized. Okay, sorry, they will be going to spend a lot of the cost for this kind of deployment. So basically, they will prefer to using the indoor distributed AP to reduce the cost. Then outdoor AP, high transmit power. The transmit power will be very high. The reason why they adjust the transmit power is because outdoor AP is most often using for the WDS point-to-point, the far distance coverage. And they need to have the waterproof and the dustproof. The next, WLAN design process. So this one is already covered on the previous slide, but they have some difference after the site survey. So right here they add the coverage mode and the device type selection. After we doing the site survey, we already understand about the application already. Like this is the office building, and we already understand we have the floor plan. We need to know the coverage, right? So which area need to have a stronger signal strength and which area it doesn't require. So after understanding about this, then we need to select the right device to deploy. Okay, the next one will be the frequency band. Okay, understand, is it require the 5 GHz or doesn't require? Link budget, capacity allocation, then go to the device configuration, engineering implementation, then the last one will be the optimization. The coverage mode, for the type indoor half open area, used for the scenario hotel lobby, the restroom, or the restaurant. We can using the indoor sector AP. To the meeting room, exhibition hall, we can choose indoor sector AP or the distributed systems. Indoor area spread by the wall, the scenario like office building or the guest room. So we can choose either indoor sector AP or indoor distributed system. The outdoor area, so we only have one choices. We only select the outdoor AP. Then the next thing we need to consider is the AP powering mode. So to understand about the network design and understand whether the environment there they have any PoE switch or not. Okay, if they have no PoE switch, then you might need to consider to purchase one PoE switch or using the DC adapter to power up your AP. And the last option, we can try to using the injector. Frequency band. So we can using the frequency used by region are specified by the country code. Okay, and the local regulation. Okay, the example, 2.4 GHz frequency band in China have 13 channels. And there's only 3 available non-overlapping channels, 1, 6, 11. The frequency band 5 GHz support 5 channels, 149 to 165 only. So check on site channel occupation and interference, facilitating frequency selection and the interference prevention. So after we're doing a site survey, try to do some calculate for the channel used by the surrounding. Okay, going to total up all the SSID and the channel. So try to using the less using channel become your on channel. The interference in the 5 GHz is greatly smaller than the 2.4. If the terminal support 5 GHz, okay, then the 5 GHz is always the recommended. Then the next one, we have the link budget. The budget link and the calculate the coverage area by giving the formula like this one. Okay, the strength. So it's the AP transmit power. Okay, the PT is the AP transmit power. GT is the transmit antenna gain. GR is antenna gain. minus the path loss and minus the loss in the cable and the component. So of course this one will be depend on what kind of the model of AP that we're using. So I can give a very simple example. So we will have one AP. Okay, so this result. So I have the EIRP. So this EIRP, after they come out from this antenna, the strength, just giving the example, is 20 dBm. Okay, 20 dBm is 20. They come out from here. So we need to calculate. Okay, this is my laptop. Okay, I have one PC on very far away. So very far away. So right now the radio wave have to deliver to my PC. So in between here, when they have one obstacle blocking in between, so they might cause some of the penetration. So now, due to the distance like this one, how far away of the distance? So example, when the wireless, the EIRP go through this distance, okay, this distance is 10 meter. Okay, 10 meter. So the 10 meter, the path loss is equal to 71 dB. It's no M, okay, it's dB. So the answer here will be 20. Okay, then it will be depend. Is it this AP will come with the external antenna? If those external antenna, okay, they have one external antenna, and this antenna will give the gain like 3 dB. 3 dBi. Okay, now the formula will become 20 is my EIRP plus my antenna gain. My antenna gain is 3. And I'm going to transmit my radio wave to my PC in the distance 10 meter. So the path loss, the further that I go, the more loss that I will have. So that's why right now between the 10 meter, I need to minus 71. So this is a 71 loss in the 10 meter. And don't forget, this one, the obstacle, they'll cause how many loss? So giving the example, this is 8. So anything pass through here, they'll lose 8 dB. So now I'm going to minus 8. Okay, then you get the answer. So 20 plus 3 will be 23. Okay, then minus these two. Okay, 79. So you become 56. And then in dBm. So when you're using the some of the scanning software from your PC, then you'll notice this one is a signal that you receive. So there's further proof why the signal that we receive is always in the negative. Then the next is capacity plan. Consider device performance, number of users, bandwidth requirement, and wireless environment. Calculate the number of required AP. Factors affecting capacity, device performance, okay, the number of the concurrent user. The device performance is those of the model that we're using. If the device we're selecting is the low spec one, so they might can't able manage too many users. And the next one is the number of concurrent user. Too many users connect to the same AP, they will cause the congested also. The bandwidth requirement, and the last one will be the interference. Application example of indoor setter AP. WLAN coverage in office building. Wire network cannot meet service deployment requirements, and it is difficult to add network interface on the wire network. So everybody have a mobile office requirement, and the visitor and guests of the company need to wirelessly access network. Okay, so this is the reason why they require the wireless. And right now, a lot of the office building is rely on the wireless already. So the requirement here, employee need to access the internet and send, receive email. signal need to cover all meeting room and the open area. The corridor and the washroom are optional. Okay, so this one is will be depend. Okay, corridor and the washroom. So if they have some special request, the washroom also you can have a very strong signal strength. Yes, then you can consider deploy one AP in the washroom. Signal must be provided continuously, and high quality signal are provided to a key area. The site design requirement. Okay, right now giving the example, they have 200 employees. Then always have 25 concurrent rate. So that means it's not 100% of the employee will go online. It's always is 75. Each user is required 2 megabits per user. Okay. Site survey. In the half open office area, the average area of each user is 4 to 6. And the office area is divided into many rooms by glass and a brass board. Device selection. So we can using the indoor setter AP with the dual band. The network design 2.4 can consider using the non-overlapping area 1611. Okay, and then they also have a 5 GHz. Then the link budget, AP coverage radius in 8 to 12 meter, and the primary signal strength is highest than -65. So you need to make sure in some of the core area, so the signal strength cannot be weaker than the -65, must be better than this. Capacity plan. The number of required AP is 4. Okay, they're using this formula to get the answer. And independent AP is deployed in each meeting room. So AP transmit power. Okay, they're giving the calculation 10 dB M1 at 2.4. Okay, 2.4 is using this one, and they have a 20 dB at the 5 GHz. Okay, this is the transmit power. Then the next, this one, description. Support 2.4 and 5 GHz frequency band and the channel multiplexing. Reduce transmit power. Each AP cover 150 to 300. Deploy an independent AP in each medium-sized meeting room. Ceiling mount or wall mount AP and use the column and the wall to control AP coverage area. Number 4, application example of indoor distributed AP. Then the background here. Hotel customer has various network access requirements. Adding the wire network interface need to redeploy cable. The long reconstruction period will affect the hotel operation. Wireless network can improve customer certification. So the hotel and employee need to access the network wirelessly. Can now no longer have people using the LAN cable to access the network, especially in the hotel. And the requirement here, the wireless signal cover each corner of the guest room. And every user requires 2 megabit per second bandwidth. Okay, of course this one will be depend on the hotel. Alright, some hotel they might not giving 2 meg. So the site design requirement, 100 guest room. Then they always will have 1 or 2 guests in a room. 2 Mbps per user. The rooms are separated by the glass and the pressure board. So the device substation, we can using the indoor distribute AP. Try to using the omnidirection so you can cover the surrounding using the ceiling mount antenna. Okay, the frequency will be the same as just now. The link budget, each AP have 6 to 8 antenna. So this is a recommended one. So even we're using the distributed AP, they can support the a lot of the antenna, but try to don't connect too many. Okay, suggest using the 6 to 8 antenna, because too many antenna you're going to use, it will weaken the coverage area and also the signal strength. So each AP cover 10 to 15 rooms. A total of 9 APs are required. So this is a transmit power, 24 dBm for the 2.4 GHz. So this is how they're actually going to deploy with using the distribution AP. So the AP, they can locate inside the ceiling here, or maybe somewhere else. So they're all using the fader line. Okay, the fader line connect to the copper, or maybe this is the splitter. Okay, they connect to the splitter and join to the antenna. Okay, so you can using this way to make the full coverage for different rooms. And the last one is an example of the outdoor AP. Background: digital campus construction, wireless signal coverage in outdoor area. The requirement: signal cover the main street. Okay, this one actually is the building. Okay, this is a block of the building or the shop lot. So, and this is the walkway, the corridor, or the street. So the signal cover the main street. Okay, we have to cover all the street, square, park, and green belt. Each user need higher than 1 Mbps bandwidth. The requirement: signal cover outdoor area, medium user density, 1 megabit per second bandwidth for each user. The distance between the building are 20 meter. Distance between the building is 20 meter. 20 meter. Okay, 20 to 30. So the selection for the device, we can using the outdoor AP only. So 8 dBi omnidirectional antenna, and another one is the 11 dB directional antenna. Okay, they're going to choose 2 different antenna. One is the omnidirectional, another is directional. Okay, the frequency band, we're using the 2.4. So the link budget when using 11 dBi direction antenna, the AP signal strength is higher than -65. Okay, within 300 meter. Capacity plan: user density is low. So each AP connect to 30 users and require 1 Mbps bandwidth for each user. Okay, this is a parameter setting. 27 dBm at 2.4 GHz. So this is how exactly they are deployed. They're putting one omnidirectional AP. Okay, this is the outdoor AP with the omnidirectional antenna. So you're going to cover the area here. Okay, they have the full coverage. Then for another area, because here they might have some blind spot, they can't able to fully cover. So they're going to deploy the AP on these 2 areas using the directional antenna. An AP cover less than 200 meter distance, and the coverage angle is larger than 120 degree. The omnidirectional antenna with the gain of 8 dBi. To cover a narrow area with a distance less than 300 meter, choose the directional antenna with the loop width 60 degree, and gain is 11 dBi. Omnidirectional antenna is installed on the pole at the street. Okay, they might hang on the pole there. Okay, somewhere at the middle here, and the directional antenna can be mounted on the wall. Okay, this one can mount at the wall, no problem. So PoE powering is used. Okay, AP transmit power can be adjusted on site. So after everything is already deployed, so we can adjust the transmit power from our controller. Then the last one here is for the WDS backhaul. The background here, a company provides WLAN coverage for building site B. okay, where does not have the wire network. Okay, the side B, the building, they have no wire network. Leasing a wire channel from the carrier requiring the high cost. So if they're going to pull the cable, okay, example, this is my side A. So the side A have the internet access, but my side B have no internet access. Okay, they require, if they're going to pull the cable connected from the side A to the side B with 2 kilometers away, the cost will be very high. So to reduce the cost problem, then this is the reason they're going to deploy the WDS in this scenario. So this requirement. Building side B has 20 to 30 mobile terminal. Okay, and then it requires more than 90% place on the site can access the wireless network, and the rate is 1 Mbps. So let's look at the requirement. Signal cover outdoor area, medium user density, 1 Mbps bandwidth for each user. After doing a site survey, there is 2 kilometer distance between A and B, and no separator is between them. Well, when we're doing the WDS, one thing we need to look to is about those of the Fresnel Zone. Okay, if you still remember the Fresnel Zone, we need to make sure the connection between the two and AP, they have no obstacle or other building tree blocking in between. Okay, if they have anything is blocking at the middle, they might have there'll be interference, or maybe they'll block our signal connections. The device selection, we're only using outdoor AP to deploy, and make sure the outdoor AP can support WDS. Okay, the frequency, WDS using the 5 GHz, and the user area is covered by 2.4. Okay, the link budget, 2 km WDS backhaul use 18 dBi direction antenna, and 8 dBi omnidirectional antenna is used. The signal strength is within 200 meters, is higher than minus 60 dBm. Capacity, there are 20 to 30 users. Each AP connected to 30 users. So 1 Mbps bandwidth for each user. So right here giving the parameter, the AP is using 27 dBm at 5 GHz, 24 for 2.4. So after deploy, it will be look like this. Right here, they're using the outdoor AP, and they have using 2 different antenna. One antenna running the 5 GHz, and this 5 GHz is the directional antenna. It will point directly to the side A. Okay, side A here also using 1 antenna, which is the directional antenna. Okay, both of them they pointing to each other in y direction. So WDS backhaul distance is 2 km, so using the 18 dBi direction antenna. Then another one is using the 8 dBi direction antenna for 2.4 GHz user access, okay, inside the building here. Okay, summary, WLAN typical application, design process, and also show you some of the example for the indoor sector AP, distributed AP, and the last one is the outdoor AP. The outdoor AP included the WDS also.